Hello friends, let us continue with our chapter 9 class 10 mathematics, applications of trigonometry, height and distances. So in the last video we have done up to I think question number 6. So today again in this video we will try to solve 3 questions, that is 7, 8 and 9. So let us look at question number 7. The question 7 says from a point on the ground, okay, so let this be the ground. So from a point on the ground, let's say the point is A. So from a point on the ground, the angles of elevation, that means angles of elevation, you're looking up. Angles of elevation of the bottom and the top of a transmission tower, which is fixed at the top of a 20-meter high building. That is like from the ground, you're looking at the angles of elevation. You're looking at the top and bottom of a transmission tower, which is actually fixed at the top of a 20-meter high building. If you have noticed the towers, especially here, we see that there are towers on some buildings. So it's something like that. From the street you're looking at the top and the bottom of the tower, which is situated or fixed at the top of a building. So if we assume that BC to be our building, then the tower will be assumed to be, let's say, CD. Okay, so that in that case we will assume the tower to be CD. So now this, as we have already discussed earlier, this will be assumed to be 90-degree ground level. Alright, so as per the question, what we have is the angle of elevation of the bottom and the top of the transmission tower, which is assumed to be CD, is 45 degree of the bottom and 60 degree of the top. It is also given that the building is how much? 20 meters high. So what are we supposed to find out? We're supposed to find out the height of the tower, that is CD. Okay, now let BC equal to 20 meters with the height of the building. Now basically what happens is when we solve, the idea is always we're getting the figure correct. Once you get the figure correct, solution will automatically come out on its own once we start solving the number of right triangles one after the other. Preferably, generally I prefer solving with the smaller triangle first and then moving on to the bigger triangles, but of course that depends, not a big problem there, it's up to you. So here I'll start with the smaller triangle, that is in triangle ABC. What shall I have here? Tan of 45 degrees should be equal to BC by AB. Now tan 45 is 1, BC is 20 meter, AB that we have to find out. So cross multiplying, what do we get? AB is how much? 20 meter. So let's keep that as it is, we might need that. Okay, now moving on to the bigger triangle, that is now in the bigger triangle, because this is done. So now the bigger triangle, that is triangle ABD. Again I'll continue with the ratio of tan, that is tan of 60 degree. Tan 60 degree will be equal to BD upon AB. Alright, now tan 60, as we know, it is root of 3. BD, now BD, of course we can see here, BD we can write BC plus CD. BC plus CD, and AB we have just calculated, that is how much? 20 meters. Okay, so now if we just cross multiply, I will have 20 root of 3 equal to BC. BC we already know, that's 20 plus CD. Now what is CD? CD is actually the height of the tower. So that will be 20 root of 3 minus 20. You bring this on this other side, CD. So if I take 20 common, I will have root 3 minus 1 equal to CD. So that is what we were supposed to find out. CD to be what? The height of the tower. So therefore the height of the tower is 20 into root of 3 minus 1. Alright. So as I said, simple question. No? We just have to get the figure correct first, that's all. Okay. Alright, let's move on to the other question. That is the next question, that is question number 8. So this question I'll just read about with the textbook. I hope you have your textbooks with you. Please take a hold of that notebook. Let's do. A statue 1.6 meter tall stands on top of a pedestal. Now pedestal is something like the stand, no? The stand on which a statue stands. That's what we call a pedestal. So if this is a pedestal, then the statue will be on top of the pedestal. So that means even the pedestal will be of some height based on with respect to the ground. So a statue is on top of a pedestal. So if we assume this to be the pedestal here, let's say the stand, the stand where the statue stands. The statue is given to be 1.6 meters tall. Okay. A statue 1.6 meters stands on the top of a pedestal. From a point on the ground, again, from a point on the ground, let's say A, B, C, D. From a point on the ground, what happens? The angle of elevation of the top of the statue. Angle of elevation of the top of the statue is 60 degree. 60 degree. Fine. And from the same point, the angle of elevation of the top of the pedestal. Pedestal, this is the pedestal, so this is going to be the top of the pedestal. The angle of elevation of the top of the pedestal is again 45 degree. Almost the same figure like the previous question. Find the height of the pedestal. So this time we have to just find out this one. So let's continue. It's all the same, almost the same question. That is question number 8. So CD is equal to 1.6 meter. B, the height of statue, and BC, the height of pedestal. So again, as I had mentioned earlier in the earlier question, I prefer solving with the smaller triangle first. So in triangle ABC, what shall we have here? Tan of 45 degree again will be equal to BC by AB. So tan 45 is 1. We will have BC by AB. So both of them we do not know, but cross multiplying AB would be equal to BC. Alright, we might need that, so let's keep it as it is. Continuing with the bigger triangle, so that's in triangle ABD. In triangle ABD, again, we shall have tan of 60 degree is equal to BD by AB. Tan 60 we know, root of 3. BD again, BC plus CD. BC plus CD and AB. Alright? Okay, so now cross multiplying we will have root 3 into AB is equal to BC. BC we do not know, plus CD is 1.6 meter. And what are we supposed to find out here? BC, because that is the height of the pedestal. So now from equation 1 we can see that AB is equal to what? BC, and we need BC. So let's not remove BC. Instead of writing AB, let us use BC. And I will be bringing this BC to this side. So that's going to be minus BC equal to 1.6 meter. This is from equation 1. Because from equation 1, AB is equal to BC. So, then by taking BC common, I will have root 3 minus 1 is equal to 1.6. So, BC will be equal to 1.6 upon root of 3 minus 1. So, now what will I do here is I will rationalize the denominator as we used to do in class 9. As we used to do it in class 9. Rationalization of the denominator. So, that will be multiplying and adding by root 3 plus, multiplying and dividing by root 3 plus 1. So 1.6 root 3 plus 1. So a plus b into a minus b. So we are very familiar with this formula now, those who have been studying regularly and sincerely. So 1.6 root of 3 plus 1 divided by root 3 squared, that's 3 divided by 1. So 1.6 root of 3 plus 1 divided by 2. Now 1.6 if we divide by 2, 1 is not possible by 2, so 0, 0.16, 1.6, so see 1 is not divisible by 2, so 0 comes, now decimal starts, so 16, 2 8s are 16, so that's when you 2 1s are 2, 0.8, so the height, as per the textbook answer, the height of the pedestal would be, I think the unit is given in terms of meters, isn't it here? Yes, meters. So it's going to be 0.8 into root of 3 plus 1 meter. Okay? Alright, so it's almost the same question, no? Like the previous question, that is question number 7. Okay, now let's continue with 9. So what do we have with 9? The angle of elevation of the top of a building from the foot of a tower. What do we have here? We have a building and we have a tower. So basically, let's just use our common sense. That is, which one is generally taller, building or in general sense, building or a tower? I think the building is always shorter than the tower, isn't it? Tower is always the longer one. So maybe I'll just draw my tower here. See, we need a lot of common sense also. Except some, maybe in some exceptional cases, other than that, a tower is always taller than a building, isn't it? A building is generally not taller than a tower. So I've drawn the tower to be CD and the building to be AB. Okay, sometimes common sense is also required. Not sometimes, every time common sense is required. And mathematics more is about common sense. The angle of elevation of the top of the building, the angle of elevation of the top of the building from the foot of the tower is 30 degrees. From the foot, this is the foot of the tower, is how much? 30 degrees. The angle of elevation of the top of the building from the foot of a tower, when you're watching from the foot of the tower, it is supposed to be 30 degrees. Done. Then again, and the angle of elevation of the top of the tower from the foot of the building. This is the foot of the building. Definitely that is going to be higher. I think it is 60 degrees or 45. How much? It is 60 degrees. Chalo. If the tower, which one is the tower? Always a taller one. Tower, which one is the tower? Is if the tower is 50 meter high. This tower is 50 meter high. Okay, no problem. What is the height of the building? So we have to find out the height of the building. So how many triangles do we have here also? We have two triangles. Triangle ABC, this side. No, if I just rub this, I think you can see triangle ABC and triangle BCD. If I just rub this, triangle BCD. Okay, so let's just solve and then let's try to find out AB. So let us name, let CB equal to 50 meter. Let it say height of, it's always good because the teacher also will be confused if you don't name. Okay, so it's always good to explain a figure a little bit, maybe not much. CD, AB, B, height of building. So that's done. And the angles and all, if you have drawn the diagrams clearly, these basic things are mentioned. I don't think it's necessary to name anything else. That's more than enough. Which triangle shall I start with? Which triangle shall I start with? I'll start with maybe this time. Okay, so let's start with the bigger triangle, triangle BCD. It really doesn't matter. Okay, in triangle BCD, we have tan of 60 degree. No, BCD. If I just remove this BCD, we have tan of 60 degree equal to what? CD, because that one dimension is already there, so that might just help me find out BC. That's why I'm choosing that triangle. Tan 60 is root of 3, CD is 50 meter, and this is BC. So BC into root of 3, 50 meter. So BC would be 50 upon root of 3 meter. 50 upon root of 3 meter. Okay, let that be equation 1 for us. Let that be equation 1 for us. Okay, now let's shift our focus to the other smaller triangle, that is triangle ABC. This one. Triangle ABC. Okay, alright. And in triangle ABC, what shall we have? Tan of 30 degree will be equal to AB by BC. Tan 30, 1 by root of 3. AB, we have to find out. BC, okay, that we got, but I'll just keep this for now for better, easier calculation. Okay, so I'll just cross multiply. That is going to be AB into root 3 equal to BC. So AB into root 3, BC how much? 50 upon root 3 meter. Okay, that will be much more comfortable for us to calculate. So now AB will be equal to 50 by root 3. This will also go down, cross multiply into root of 3. So that's going to be 50 by 3 meters. So as per the textbook, so that's the height of our building. But as per the textbook, they have simplified that. 3 ones are 3, 2 left 0, 3 6 are 18. So we have the remainder 2. So they have given the answer in mixed fraction. I hope you still remember. It was done a long time ago in your lower classes. So this 2 goes up here, divisor goes down there. When you have to represent in terms of mixed fraction. So it's going to be 16, 2 by 3 meters. So that is the height of your building. Okay, so as I promised, only 3 questions. Alright, so let's just stop there. And we'll continue the other questions in the next video. So please do watch till the end. If you have liked it, please do subscribe, share, and let people know if it was of any help to you. Alright, so till then, see you in the next video. Take care all of you. Bye bye.